Okay, hello everyone. My name is Magnus Hagander. I'm here today to talk to you about Postgres 13 and what's coming up new in the upcoming version of Postgres. So at first, a couple of quick words about myself. As I said, my name is Magnus Hagander. I work for a company called Red Pill Linpro, which is an open source services business in Scandinavia. So I'm based out of Stockholm in Sweden myself, where we do sort of a bunch of different things around different open source products, where my focus is on database side, primarily on Postgres, of course. That's why I'm here, right? I'm also a member of the Postgres project itself, of course. I'm a member of the core team, one of the committers who supposedly were writing these features, though I realized 13 is actually one of the first versions of Postgres where my name is not in the release notes anywhere, but let's see if we can improve that in the future. And finally, I'm serving on the board of Postgres Europe, which is the user group and advocacy coordination NPO around Europe. Amongst other things, we run conferences, things like that in Europe. Of course, that's, all of that is slightly out the door right now, where we haven't been running these type of virtual conferences, but it'll be interesting to see how well that works out as well. So enough about me. Let's talk about Postgres, and let's talk about Postgres 13, which you can say at this point that Postgres 13 is almost done. It is not entirely done. As you know, you can't actually get the release and start using it, but we're getting very close. If you take a quick look at how the development of Postgres 13 has gone, it started technically in July of 2019 when we branched Postgres 12. So we basically created, and the way we do releases in Postgres is we decide we're done, we create a branch called release 12 stable, and then by definition release 12 is now stable, right? Well, maybe not. The idea behind that is at that point we open up the master branch for development into what will eventually become Postgres 13. And then we work in the Postgres community with something we call commit fests. It's just sort of our name and our words for how we do iterative development. The idea is we spend 1 month writing features, and submitting patches, and then we spend 1 month reviewing and getting these patches committed, and that's the commit fest. So for Postgres 13, we ran 5 of these. We ran one in July last year, one in September, one in November, one in January, and one in March. And they're all, the idea is every commit fest is 1 month exactly, except for the last one, which can be up to 2 months or what it takes. It was a bit over a month, but less than 2 months this year. And that finished then in April of 2020. And then the current state is that in May, a couple of weeks ago, I guess a couple of weeks more, because I'm doing this recording a bit ahead of the conference itself, we've put out beta 1 2 weeks ago. And that's the current state. When you are listening to this at the live conference of Postgres Vision, we may have had a beta 2 out. Don't know. If it is, then just sort of mentally change the name. Now, once we have hit beta version, we are reasonably certain that the feature set is complete. At this point, no new features can be added into Postgres 13. We may remove features out of Postgres 13 if they don't work. If we find bugs in them that are not readily fixable, if we find architectural problems that just have to be done differently, there is a chance that features will be removed. So there is a chance that the features that I talk about in this talk may be removed, but there will be nothing else added. Of course, there are some other features that I may not mention because there's too many new features. They're still there, but nothing new goes in. So let's start looking at these. Some of you may have seen me do this type of talk before. I've done this talk for the new version of Postgres for many years now. And I try to set them up along approximately the same structure, which is I split them up into 4 pieces. I talk about DBA and administration, talk about SQL and developer, backup and replication, and then finish off with talk about performance-related features. Now, of course, there's always like, what's a DBA and what's a developer? That's always like a gray line. So I just decided, because I wanted 4 sections instead of 3, to say, well, DBA is things that are primarily not done as SQL, and SQL and developer are primarily things that are done in SQL. But in the end, in a modern organization, like the split between DBA and developer doesn't really exist, right? We all work together to get things working. So that's sort of the general split. But before that, let's start and single out one feature. I'm sure you've all used the feature drop database at some point, right? You want to drop a database, and we've modified it. We've added some new abilities to this ability. Basically, I'm sure you've all done this, right? You've done drop database production. Probably not, or hopefully not, if it was actually named production, but maybe it was just named something silly like DB01, and you thought you were somewhere else, and you did a drop database production. And what happens is it hangs, right? It doesn't actually drop the database. Why doesn't it drop the database? Because there are users connected to it. That's sort of a safeguard, right? So you don't accidentally drop. Now we've fixed that for you in this version, so you can now just say drop database production with force, and then it'll just disconnect everyone and drop the database. So you don't have this pesky production thing anymore. Yeah, maybe not do that on production, but there are certainly good use cases where if you need to drop a database where you have like a testing application connected or something like that, you can, again, add the with force and the database is gone. The only exception, I believe, is if you yourself are connected to this database, then you can't even apply force to drop it. You just have to connect to a different database and drop it. So anyway, speaking of breaking things, there are a couple of changes that may break, like your scripts and things like that in Postgres 13. There's not a lot of them. It's not like back in Postgres 10 when we broke every single script you had. So we try to minimize it, but there are a couple of them. One of the big things that a large number of the wait events that are in Postgres have been renamed. Right? The upside is that they're much more consistently named now. And there were a bunch of new ones added, which is where it became just obvious that there was no real consistency in how these things were named. But this may cause issues with your monitoring. If you are monitoring on specific event names, then you may need to update your monitoring scripts to look at the new event names. They're mostly things around locks are the big thing where almost everything has been renamed, but there are a bunch of others as well. So if you are doing that, you'll want to look into exactly what has changed. If you're just collecting statistics on all your events, all your wait events, then it should just update automatically and show you the new numbers. So then you'll be fine, but you'll want to pay attention to it. Now, the thing that might break more things, it's that all the timing columns, if you're using pgstat statements, and if you're not using pgstat statements, take this as a good time to start using pgstat statements because it's great. You really want to be using it. But all the timing columns, that is total time, minimum time, maximum time, mean time, and stddev time, have all been renamed. They're now total exec time, min exec time. So we put exec in there in the middle of it to specify that this is the time spent actually executing the query, not including things like transferring data and planning the query. We'll look at a bit later at exactly why this happened, but the breaking change here is this rename. So if you're at any point selecting these to snapshot them into a table or to pull them into monitoring somewhere, they're named something else now. So you'll want to take care about those. Now, having said that, let's go into the sections that are the actual features that we're talking about here. And let's start around the area again of DBA and administration. If you are using the extended statistics, as we call it, where you say create statistics and create a statistics on a combinational column, you can now change the statistics target individually on these extended statistics. Previously, you could only change it on the underlying columns, but now you can also change it on the combination that is in your statistics. And it turns into one of these wonderful commands that you do this by saying alter statistics, give it the name, set statistics. And that's the same as you would on the underlying column, say alter column set statistics. So it sets this, the portion of the table that we look at and the size of the data that we look at as we collect these statistics. Moving on, we now have a progress report. As you know, a number of versions ago, we started adding progress monitoring in. We added basically one, which was vacuum. In the latest versions, we've also added things like create index and reindex. Now there's also a progress monitor for analyze. which will tell you how far along is this analyze and how much data has been generated, so that you can know if you're running a large analyze on a big table, how far along is it. Probably not as important as looking at it for vacuum, because analyze is just generally faster, but still an important part to keep track of. The reindexdb command is now capable of reindexing multiple indexes in parallel by just saying reindexdb-j to say, do 10 indexes in parallel. This is only in the command line version of it. So if you're using the reindex command itself, you still have to, you yourself have to open like 4 connections. But it lets reindexdb open multiple connections and run multiple reindexes at the same time. Now, one thing to consider here, don't forget about your maintenance work memory, right? So you might say, well, I'm going to reindex lots of things real fast. I'm going to run it, across 16 parallel processes. And then you assigned a lot of memory to each of them. Maintenance work memory is used in each one of these. So if you do it across 16 parallel processes, it will use 16 times maintenance work mem. So you'll have to find a balance there somewhere. It might be better to reduce the maintenance work mem, but most of the time, it's probably better to not put the parallelism up so high that your memory just isn't enough without reducing the maintenance work mem. But it can certainly help if you're doing like large data loads or restoring data from a dump or something like that, to be able to parallelize this operation properly. There's also a certain amount of parallel vacuum. I mean, it's partially parallel vacuum because the vacuum itself is still serial. It just does the one table. But vacuum will now be able to process multiple indexes on the table in parallel when you're vacuuming a table that has more than one index. So again, these are all about speeding up. You just say here, well, you say vacuum parallel, and it will use this parallelization feature. And you can control exactly how many indexes it can do in parallel and things. But those are all about when you need to run reindex or when you need to run vacuum manually, which is, and you want them to finish as soon as possible, which is during normal operations. We don't want this to happen, right? During normal operation, we want to use Autovacuum. And Autovacuum works really well in most cases, and you'll need to go to these with data loads, and you'll need to go to these when your Autovacuum is not keeping up. And speaking of that, there's been an important enhancement to Autovacuum as well. In previous versions of Postgres, Autovacuum would trigger vacuums based on updates and deletes, and it would trigger analyze based on number of changes. Now, there's now a new trigger for the vacuum, which is it can also trigger on the number of inserts. Previously, if you had a table that was just insert only, it would only ever get triggered for a wraparound vacuum, which means that it was getting so long that it needed so long ago that it last had a vacuum that it needed a full freeze run. And when you did that to the whole table, that could be very expensive. Now, the idea here is by setting these new parameters, which are Autovacuum vacuum insert scale factor and Autovacuum vacuum insert threshold. So wonderful parameter names, but they're similar to the previous ones, except they now look at inserts. So by default, for example, the scale factor is at this point, that may change before the release, but at this point, it's also set to 0.2, which is the same as general regular vacuum, which says when you have the 20% has been inserted, will trigger a vacuum. So the idea here is we'll trigger vacuums earlier on tables that are majority or only inserts. And the idea is by doing that, they'll be in better shape once they hit the time. Like they won't hit this anti-wraparound vacuum that gets very expensive. Instead, we can split that up into multiple, more frequent runs, where the total cost and the total time spent doing vacuum might be higher in total, but it gets spread out over much more time, and every one of them, every individual one, becomes a lot cheaper, which is the whole idea behind doing it. And then, of course, you also have the threshold, which works just like the regular vacuum threshold of making sure you don't end up running this after inserting just a couple of rows. This will help you in the cases of large insert or primarily, not insert only, but primarily insert workloads. We've added support for slow query sampling, which is a way if you're using slow query logging today, using log min duration statement, it'll log everything, and this can be very expensive if you end up logging a lot. The idea with slow query sampling is you set up the system to say, well, log 10% of my queries, right? And we assume that's representative enough. So it's sort of a halfway in between. If we're using pgstat statements, we'll just log the completely denormalized version of the query, or we won't actually log it. We'll keep cumulative statistics on it, whereas log min duration statement will log everything for the queries. And by doing this, we can set it up to log a portion of it, which makes this logging cheaper, because actually doing log min duration statement with a very low time, meaning you log a lot, can be really, really expensive and very bad for your overall performance. So you can do this by setting. So we now have a new parameter called log min duration sample, which is the new version of log min duration statement, if you will. And then we have log statement sample rate. So in this example configuration here, it will log the sample rate 0.1 says it'll log 10% of the queries that take more than 100 milliseconds. If you set both this and log min duration statement, then it's still that log min, everything that goes above log min duration statement will always be logged. So you can, for example, have log min duration sample set to 100 milliseconds and log min duration statement set to 5 seconds or something to catch the longer running queries in that one. So they do still both work, and they work together. Further on the DBA side, there's a bunch of changes to the Postgres SSL support on both the client and the server side. First of all, Postgres now requires OpenSSL version 1.0.1. That should really not be a problem to you. It's in any even remotely modern Linux version, for example, has OpenSSL newer than this everywhere. So this really should not be a problem anywhere. But if you have a really old platform somewhere, you might, in theory, have problems building against that. What can potentially be a problem is that we've changed the new default minimum version of SSL to be TLS version 1.2. That can break if you have old clients. If you have old clients somewhere that are talking to Postgres via SSL and they don't support TLS 1.2, because we don't force you to upgrade all the clients, then you may need to lower this. And you can then go into postgres.conf and change it from TLS 1.2 to TLS 1.1, for example, to make these work. But if you don't have to, don't do that, right? Most clients will definitely support TLS version 1.2. You also now have the ability to enforce this on the client. You can set the minimum and maximum protocol version in the libpq connection string on the client, whereas previously you could only enforce it from the server side. So to prevent downgrade attacks, you may want to set the SSL min protocol version on the client side. You can now also provide the password to unlock the key into libpq, so in the client connection string, or you can set an SSL key pass hook, which is a callback to get the password. So Postgres will call your code and say, give me the password for the key as we use it to do certificate authentication. If you're using Scram authentication and you're using SSL, you can now, again, on the client side, say channel binding equals require, at which point you will require that channel binding is used. Previously, Postgres would use channel binding if it could, but it would continue to work even if it couldn't, which, of course, from a security perspective, is not the best choice. And again, channel binding is a feature specifically for Scram authentication, so it only works with Scram and SSL together. Based on top of these, Postgres foreign data wrapper, if you're connecting from one server to another, it now supports SSL key and certificate instead of using users. And you can specifically, if you are a super user, you can specify that the password is not required on these, so that you can use things like peer and GSS authentication. Now, unfortunately, you still can't do GSS pass-through with it. So if you're using GSS authentication between two Postgres servers, it will authenticate as the Postgres server, not as the end user that connected to the first Postgres server. Further, on SSL, pgstat SSL will now only contain rows for actual connections. It previously actually included rows for background processes where the actual SSL data would always be null, which is kind of pointless. They've been removed. Same thing for pgstat GSS API, which has similar types of information. This may potentially be an issue if you're doing an inner join to get these fields together with other data and you actually want the background processes. In those cases, you just change that to a left join and you'll be good. On the statistics side, there's also a brand new statistics view called pgstat SLRU, which means it contains statistics about our SLRU structures, which are they're simple, least recently used structures, but these are things like PG exacts, PG subtrans, PG multi-exacts, and all of these things are now available with some basic IO statistics in pgstat SLRU. pgstat activity, which I'm sure all of you have used at some point, it now has a new column called leader PID. This shows if this is a session that participates in parallel query, it will show the leader of this parallel query. Previously, you had no idea, but you had no way to actually map a worker to which leader it was working for. You could try to map them on a query string, but then if you had multiple ones that were running, things like that. So this, you can just join it and basically join it back to pgstat activity again to find your leader based on this leader PID column. And if it's null, then it's a non-parallel query. So that part's pretty straightforward. We've added the concept of a trusted extension, which is an extension that can be installed as a non-superuser. This has also replaced what we previously had in PL templates, and they're all just regular extensions now, or with this trusted flag. So basically, any extension that has a flag set that says trusted equals true, you set this in the extension control file, any user will be able to say create extension. So this should be an extension where all the functions that are part of the extension have been verified to be safe, right? And there's a whole bunch of the built-in ones that have been migrated. So things like the btree gist, the interarray, the PG crypto, the typical type of extensions that add things like data types and and those things that are safe will have this flag set as being trusted. And as part of this, we've also removed support for unpackaged extensions. That's actually for upgrading from an unpackaged extension to the current version is no longer possible. Now this goes back to like Postgres 9.1 or something before we had extensions. The idea is we could upgrade things like PG crypto from before it was an extension into the extension mode. We can no longer do that, but all you have to do is make sure that you upgrade it into being an extension before you upgrade to Postgres 13, and you'll be fine. So moving on and heading over into the areas of SQL and developer a little bit more. If you're using generated columns, this would be generated always as identity or generated as a value. You can now drop the generated part, which I guess was just an oversight in the previous version. So when we've created one like this here in this example, for example, column is a generated always as 2 stored. Now you can just say alter table, alter column, drop expression to get rid of that one. If you wanted, and then it will be converted to a regular column of this value, and then you can start changing the value. We now have a built-in UUID generator that covers most cases of generating a random UUID. Previously, you had to install either the UUID OSSP extension or the PG crypto extension to be able to do this, and you should have installed the PG crypto one, which generates good random numbers. But now you can just use the function genRandom UUID, which will give you a random UUID. And this one's built in with no need for any extension to use this anymore. The UUID OSSP extension is still there if you need to generate any types of UUID that are not random. But if you just want plain random UUIDs, no need for an extension anymore. It's all built in by default. The Postgres JSON path support that was added in the previous version, the SQL standard syntax for extracting and querying JSON data, it now supports datetime. which is kind of a weird thing because JSON doesn't actually support datetime, but it basically has a built-in datetime parser. So as you can see in this example here, we can run a JSON-B path query against the JSON-B structure and actually say, in this take the string that's in the key T, that's the $.T, apply the datetime function to it. Is it less than this other thing? Apply the datetime function. That ensures that we're comparing the values as date times and not as strings. It's one of the, I think it might have been the only thing in JSON path that Postgres did not have in the previous version. We've added support for SQL standard function fetch first with ties. We already had the standard function fetch first n rows only. This is similar for those of us who've been working with Postgres for a long time. This is what we've usually written as limit in Postgres. But the SQL standard syntax for it is as in the first example here, which is select star from n, order by, fetch first 2 rows only. That's the SQL standard way of saying what we'd previously in Postgres say is limit 2. But what this new feature lets us do is we can say fetch first 2 rows with ties. And the ties part, I'm sorry, fell just outside of the slide here. And the difference being here, so this table just has the numbers from 1 through 10 in it. And I order by saying give me the first 2 rows, I get a 2. But then if I add a second 2 to it, actually it has the numbers 1 through 10 and it has 2 2s. That's the whole point. Then when I say with ties, it will get me the first 2 rows, the 1 and the 2, and then it will give me every other row that has the same value as the last row. So it'll get me the second 2 here as well. When you do this with ties, the order by is required. Like you can't get ties if you don't sort it first. So order by is required, and then you say with ties. So you can get more rows than you actually specified, but only if they have exactly the same value in the order by column. So moving into backup and replication, there are some exciting and very useful features around this. When you're doing archive recovery, that means when you're doing point-in-time recovery, Postgres will not fail if you hit the end of your archive log without reaching your point-in-time target. So if you've set a point-in-time target that's further into the future than you have archive log, Postgres will just get there and then shut down. Because this is usually either a misconfiguration thing. Maybe you accidentally put in the wrong month or the wrong year for your restore. I'm sure we've all made that mistake at some point. Or it's an archive issue where, for some reason, Postgres is failing to retrieve files from the archive where they might actually still exist. So if you have specified a point-in-time target, whether it's in time or in transaction or where it is, it will fail if it gets to the end without reaching the target. If it hits the target, it will follow the usual pattern. And if you don't specify a target, it will still run through the end and open as usual. It's only if you specify a target, but that target is never reached, that has changed. There is a new view added on the backend called pgstat progress base backup, which shows you the progress while a base backup is running, so you can see how far along it is by looking on the server side. This is similar to the -p that you can give to PG base backup, but then you see it on the client. So maybe you had a backup that started from a cron job that didn't have that on. Well, then you can look at it on the server side and see how far along is this backup. Now, this applies to base backups taken through the replication protocol. So basically, PG base backup. If you're using an external backup tool that uses the raw backup APIs like Backrest or Barman, they will not show up in pgstat progress base backup. They'll have to implement their own level of progress information. But this one is really useful for the sort of basic base backup. Another enhancement is we now have backup manifests in Postgres. They're included in PG base backup by default. You can turn them off, but why would you? The manifest is basically a file that lists all the files that should be in this backup and the checksums of all those files. And you can choose between a bunch of different checksum methods if you care. Built-in one's probably fine. I think it's CRC, that's the default. And along with this comes a new tool called PG Verify Backup. So if you have a backup folder somewhere, you can point this PG Verify Backup on it. It'll read the manifest, and it'll verify that all the files are correct according to the manifest. So that you haven't lost any files, or a file has somehow become corrupt and is missing data or anything like that. Again, these are for the are on by default in your PG base backup level backups. If you're using an external backup tool, you'll have to configure that tool separately to deal with those things. There is a new wonderful parameter that can corrupt your database called ignore invalid pages. If you set this, Postgres will ignore errors when it does archive recovery or crash recovery. You really don't want to do this, like ever, except of course when you do. But it's like a bunch of the other tools. If you get an error that is basically saying your recovery is corrupt, ignoring that error means you're accepting the fact that your recovery is corrupt. You only do that if you have no other choice left. But if you have no other choice left, then maybe you have to. And yeah, then you do it. But you try to stay away from it. Postgres logical replication now supports partition tables. So it will do so if you add a partition table to publication. Each partition will still be replicated separately as the individual partition. You can also set a parameter called publish via partition root. You set this on the publication. It will then make it look like all the rows came from the partition root, so that you can, for example, replicate from a partition table into a non-partition table. And it also supports receiving data into a partition table, which means you can replicate from a non-partitioned into a partitioned one. It can be a very useful way of actually creating a partition table. Or you can replicate between different partition structures and things like that. So this was basically just a missing feature in the previous versions. You're also now able to control the amount of memory used for logical decoding, which is the foundation of logical replication, by setting logical decoding workmem. When it runs out, it will spill to disk and use temp files, and you will get in the pgstat replication view will tell you spill counter and spill bytes, like how many times has this happened and how much space was used. The default here is going to be 64 kilobytes. If you have lots of large transactions, you may want to consider increasing it. But of course, like with all memory parameters, that means you're using more memory. If you set up basic replication, just a replica, it will now use a temporary replication slot by default, unless you've explicitly told it not to. That means that while a replica is connected, it will not fall so far behind that it has to disconnect, right? But since it's a temporary replication slot, if the replica actually disconnects, the master loses all knowledge of it and may delete WAL that it needs. Now, normally, if you do replication, you should really always use a replication slot. That way, you have things under control. Now, the biggest problem of using such a replication slot is, well, if you kind of forget about it, then you will run out of disk space on the master server instead, if you delete the replica and don't delete the slot. And to handle that situation, we have a new parameter now called max WAL slot keep size, which will tell you that, well, a slot that needs more than this extra WAL to be kept around will be killed. So if you forget your replication slot, it will get deleted at some point. You can set a cap on it in size. It also means that any replication or archiving that's using this replication slot will at that point fail. So this is a little bit similar to the old way we did it with WAL keep segments, except this one will only keep the data around if it actually has to. As soon as the replication slot is moving forward as it's supposed to, it will not keep any extra data around. And you now have the ability, this I think was one of the main reasons why in the previous version, recovery.conf configuration was moved into the main configuration file, is the ability to change parameters without restarting the system. And of course, then we didn't actually get any of those features into that version. But now in 13, you are able to change the primary coninfo and the primary slot name, either in the config file or using alter system. And then you just need to reload Postgres. You don't need to restart it. So for example, you can have your replica with running queries on it, change to pull data from a different replica, pull data from a different master. For example, if you fail over your master, you can repoint your replica without having to restart it, without having to disconnect users and cancel their queries. So let's finish off by talking a little bit about performance. There are a couple of things. These are mainly things that will sort of just benefit you without having to do anything, which is the best kind, right? We have support for something called incremental sort, which will optimize a multi-level sort where you have a query that at a lower level of a query plan is already sorted by part of the key, and then you want to sort it by something else. In the simplest case, you have an order by on two fields, order by A, comma B, and you have an index on A. Then we can now actually use the index on A to get the data sorted by A, and then only sort these, sort of split it into pieces by each value of A and sort them by B at the upper layer. But this applies across all sorts of lower levels. So it doesn't have to be an index scan. It could just be another part of the query. It could be a merge join. It could actually, it could come out of anywhere. So this can make sorts where you have partial sort key pre-sorted much, much faster, and in particular use a lot less memory because it only has to sort these sort of individual buckets, and then it can move on to the next one. Our hash aggregates can now spill to disk, which they couldn't do before. So when workmem is not enough, our sorts would spill into these temporary files. Our hashes wouldn't. This had 2 points. One of them is that in a lot of cases, like Postgres did an estimate on the hash, and if it wasn't sure that this was going to fit in memory, it just wouldn't use the hash aggregate. Now that it can spill to disk, it now has another way of running these, even if it knows it doesn't fit, right? And also, one of the bigger problems was that if the estimate that Postgres has was bad and it said, hey, this is going to fit in memory, and then it ran the query and it turns out it didn't fit in memory, then it would just allocate memory with no bound until the OOM killer would kill it and everything would be bad. Now it will dynamically switch to use these spill files, in this case, making these queries much safer and make it more safe. So these are hash-based aggregates. They're used for group by, they're used for distinct, they're used for grouping sets. Right? These all now have ways of running that can be faster. Our explain and our PG stat statements can now track wall usage. So you can see in this example here, we're saying explain, analyze, comma, wall. That's the new one. It can now see, as you will see on the second row of the explain plan itself, it says this one created one wall record, 59 bytes. Like this is information that lets you know how much transaction log is being generated in each step. And similarly, these have been added to PG stat statements along with planner statistics. And the fact that we added planner statistics is the reason why these execution statistics have their columns renamed. Because if you look in PG stat statements now, not only do you have the total time was renamed to total exec time, which is because you now have total plan time and minimum plan time and maximum plan time, and the number of times that this query has been planned, which may be different from the number of times it's been executed. And then you have the three new columns, which is WAL records, WAL FPI, and WAL bytes. Number of records, number of full page images, and number of bytes of WAL that has been generated by this particular query. In this case, my insert into, which is kind of a boring query. With deduplication support in the btree indexes, basically for indexes where you have many duplicates, this can massively reduce the storage, which will, of course, improve performance. I think we can expect it to do that in sort of like almost every case. There is a tiny overhead of it if you have an index where there are no duplicates at all. But that is probably a fairly small, it's only an overhead on writing, and it's very small, but you can turn it off in those cases. But in general, this is one of those things that if you have duplicates, and these might be a duplicate, like partial duplicates and things across all the columns, it will reduce the storage, and everything that reduces the storage size is a good thing, right? So this is probably going to make a bunch of your indexes smaller. Now, if you are upgrading with PG upgrade, you have to reindex to be able to use this new feature, right? It doesn't automatically, like it has to change the existing indexes to make it work. But when you do, it'll probably pay off quite a bit. So in these cases, like I've mentioned a bunch of features. What I usually say at this point is I'm sorry if you were in the room and I didn't mention your feature. I guess I'm sorry if you're watching the stream and I didn't mention your features. There's always more features than you can mention. There is hundreds of features in the new version. Lots of performance improvements. There's no way to cover them all in just one of these talks. There'll probably be something else that hits you exactly what you need that just doesn't hit enough people that I can mention it here. But at this point, we need your help, right? Please help us. Download and test the beta version at this point. There are apt packages available if you're using Debian or Ubuntu. There are RPMs and Yum packages available if you are using Red Hat or CentOS or Fedora or those things. Just please download them, run them, see if they work. Run your tests against them. We want to know if we broke something, number one. We want to know if something works worse. Something may be slower for you. If you can let us know that during beta, it's much, much more likely that we can actually get this fixed before the release is out. Point your unit tests at it. It may be a little bit too early to move your production to the beta version. We know we have some people who sometimes do that, but it's not too early to move your test to it, right? Get testing done on it and do it as a way to help us out and to help yourself out, right? Because if your version is then going to be better tested on 13, and 13 itself is going to be much better tested for when we're ready for the release. So please go ahead and download that. Go to the website, hit download, and test it out. And let us know how it works. That's all for me this time. There's a little bit of time for questions, so I'll be happy to take anything you've written during the talk, or if you want to bring them up now. So thank you very much.
All right, Magnus, that was great.
Thank you.
Got a lot of chat activity. I had trouble kind of keeping up with it, but we should probably do the Q&A questions first, and then we can look at some of the chat ones. We only have a couple minutes, though, of course. Probably the big one was the issue of renaming some of our columns.
Yeah, I think that's a topic to the ones in pgstat statements. That's always a contentious topic. What's most important, making them consistent across the whole view, or keeping backwards compatibility? I think an argument can be made in both directions. I'm personally not convinced that the renaming was the right choice, but it's sort of like the long-term win is by keeping them consistent, and the short-term win is by not breaking the compatibility. So it can be a tough one.
Yeah, definitely true. Definitely true. We talked about one of the things you talked about was the use of auto vacuum and running vacuum on tables that are insert only, and that was going to improve the issue with long-term freezing. But there is another value to that, right?
Yeah, there is also, if you have tables where you're able to use a lot of like index-only scans, then index-only scans are only available once rows have been vacuumed enough to flag them as fully visible. So if you have an insert-only table, it will not be able to take advantage of index-only scans unless you vacuum it. So yeah, the Autovacuum triggered by inserts will help in that scenario as well.
Somebody asked about the ability to change an extension from trusted to untrusted. I don't know the answer to that one. After
the fact, yeah, I don't know. I mean, before you install it, you can go edit the control file and change it. And I believe we parse the control file when you create the extension. So.
Right, but of course we made it trusted or untrusted based on our analysis of how safe the extension was. So maybe changing it's not a great, maybe not a great approach.
Yeah, I mean, one way or another, you either have to trust the extension author to flag it correctly, or you just have to review the whole thing yourself and decide based on that, and then you can edit the control file if you don't agree with the extension author.
Sure. Let me throw a softball question at you. When is Postgres going to support LDAP authentication? That's like it's right up your alley there.
That's got to be some 10 or 15 years ago, right? Postgres has supported LDAP authentication for a long time, so I'm wondering if that might be. I see the question as well, so maybe it refers to some specifics within LDAP authentication that we don't have, but generic, like we do have well-working basic LDAP authentication since quite a few years now.
And I'm just going to throw the last one at you. If somebody's asking if we can have separate wall for individual databases, and that seems to be coming up a lot recently. We normally tell people to create separate clusters for that.
It's coming up. I think there could be a lot of value to it from the ability for replication and in particular point-in-time recovery, but I think it's a much harder problem than it might seem at a first glance. And I don't know of anybody who's actually working on that right now. Because we have.
Well, thank you very much, Magnus. We are unfortunately out of time.
In connection with all the other things.
I know.
Thank you.
True, very true.